Which statement describes the motion and the arrangement of the molecules in a gas? Let's go through the options. Molecules move randomly within an ordered arrangement. Okay, this part is wrong because the gas molecules, they move in random arrangement. So option B, the molecules move randomly within a random arrangement. This is the correct answer. Option C and D says that the molecules vibrate about a fixed position. This is only the case for solid molecules. So C and D are wrong as well. Stars form in space from huge clouds of hydrogen atoms that attract each other because of the force of gravity. So as the atoms attract, the cloud gets smaller and the atoms move faster. So as the atom move faster, we know that the kinetic energy increases, and this will cause the temperature to increase as well, because we know that the kinetic energy of the atoms is related to the temperature. So we look at the option, the temperature must increase. Okay, next column we have the pressure. Okay, pressure is the force acting per unit area. So as the atoms move faster, they collide more vigorously and more frequently. That will increase the force exerted. So if the force exerted is increased, the pressure will increase as well. So we have the answer as B. It takes 0.2 seconds to generate one complete wavelength in a ripple tank. Okay, so that means the period is 0.2 seconds. And the wavelength of each wave produced is 4 cm. What is the speed of the wave? Okay, given the period, right, we can find out what is the frequency. Frequency is equal to 1 over period. That will be 1 divided by 0.2. We have 5 Hz. And to find the speed, we can use the formula F lambda. That will be 5 Hz times 4 cm, which is the wavelength. We will have 20 cm per second. Answer D. What is the reflective index of a medium? Okay, this is a recall question. So we know that the reflective index can be expressed as the speed of light in vacuum divided by the speed of light in the medium. Okay, so the answer should be D, the ratio of the speed of light in vacuum to the speed of light in the medium. A ray of light is incident on one side of a rectangular glass block. So its path is plotted through the block and out through another side. So which path is not possible? Okay, looking at option A, the light ray travels from air to glass. So it travels from an optically less dense to a denser medium. So the light ray will bend towards the normal. So this is correct. And at this point, right, the light ray moves from glass to air. It's from an optically denser to a less dense medium. So the light ray bends away from the normal. So A is correct. For B, B is wrong. So let's just zoom in into the part where it is incorrect. Looking at this portion here, the light ray is moving from glass to air. From an optically denser to a less dense medium is supposed to bend away from the normal. Whereas in this case it is bending towards the normal. So this is incorrect. Okay, now let's still look at option C and D. Option C, at this point, from air to glass, it bends towards the normal. And at this point, let's draw the normal. From glass to air, it bends away from the normal. So this is correct. And for option D, from this point to this point, air to glass, it bends towards the normal. And at this point, the angle of incidence is greater than critical angle, so it undergoes total internal reflection. And at this point, from glass to air, the light ray bends away from the normal. Okay, so the answer is B.